Hi, this is Tom Walski from Bentley Systems, and now I'm going to be talking about the third part of our series on importing SCADA data, and this is going to be importing SCADA data using our WaterGEMS SCADAConnect, in particular the SCADA element as a way to bring SCADA data into a hydraulic model. Okay. There are a lot of things you need to do to get started in this, and the most important one is just to understand your data sources. Now, we have two ways that we can get data into WaterGEMS. One are through data files. We'll call those database imports. They could be a whole variety of file types, and we'll show those. And the other one is to go directly to the SCADA OPC server. This is the server that accepts the data from the communication system and serves it up to the SCADA human-machine interface and historians and other SCADA features. So there are two ways to get to data. We're going to also talk about the SCADA element. This is a modeling element that we now have in WaterGEMS and WaterCAD that actually represents the SCADA signal. So it's this element that will appear in the model, but instead of being a physical thing like a pump or a pipe, it is just a signal. And it's important when we get started here, we talk about data sources and these new elements, to understand your data. Before you get into trying to bring it in, understand the format, understand how the columns or the attribute are lined up, what the attributes are named, what the units are to data. It's very important to know your data when you get started in this kind of effort. So the data import, we have three different ways of doing this. We've talked earlier in other talks about bringing in observed data into a graph or bringing in time series field data. And now I'm going to move on to the next element, which is a SCADAConnect element. We also can bring in data for Darwin Calibrator as well. So when we talk about database file types, what kind can we support? Well, right now in 2015, we have this list of data files. So if you can get your SCADA data into one of these files as you import it out of the SCADA system, then it's possible for WaterGEMS to read it and use it. We're going to be using Excel in this particular case because it's one of the easier ones to work with, but you have some very general ones like ODBC and OLEDB, which essentially lets you get pretty much any kind of database data available for import into WaterGEMS. Okay. Now there are two different file formats that we support in this. We have the data should be in a format where we either have one row per value, that's the top one here, where you would have a date and time field, you would have the name of the signal, or tag as they would call it in the SCADA system, and you would have the value, and then you optionally could have some type of quality indicator. Is this data good or bad? Okay, if you get something like NaN, not a number, then that's really bad data, so you don't want to bring that in. So we have, these are just the minimum that you need in the file. You may have a lot of other stuff in your SCADA file, in your database, but this is what you really need. So we have this style here where there's one value per row in the file, or one value per record if you're working in database terminology. The second style we have are multiple values per row. So now the name of the tag, instead of being placed in each row, is put on top of the column. So you still have the timestamp, but now it can have multiple values at a given time. So this given timestamp, you may have the flow rate, tank level, pressure gauges, and the flows. You have all kind of data on one row. This is usually data that's been processed a bit. The top format is more likely what you'll see from raw SCADA data, while the bottom format is more likely what you'll see if someone has gone through the data and organized it and massaged it a little bit. But we can take either one of these, but the data basically has to be in this format. Now, one of the main things that you have to do when you're working with this data is understand the tags. A lot of times they don't have intuitive names like South Tank or something of that sort. Instead, they have values like 71549. And you've got to find that dictionary that tells you, okay, what does that tag name correspond to? What real signal does that tag name correspond to? So that's one of the main tasks of getting set up to do this kind of work. If you get data from an OPC server, it might look something like this. Usually there's a channel and device and a tag name. And it'll tell you what type of data is it, what the numerical value is, what the timestamp is, and another quality indicators, which you'll likely find. This happens to be from Kepware, but there are a lot of SCADA servers out there that use something like this. So when you work with OPC data, this is kind of what the data would look like if you use that route of going right into the OPC server. Okay, so what's the workflow for bringing in data? Well, we start out with two things, our hydraulic model and the SCADA system. Okay, those are the two things you need as a starting point, obviously. Okay, from the SCADA system, what you need to do is tell WaterGEMS where the signals are. What's the file name? What's the name of the OPC server? Where is it located? Is it on a different computer? Is it on this computer? Is it on the network? Is it on the cloud, for that matter? So you have to define where the signal is and what format it's in. And then you say, out of all the signals we have in this SCADA system, these are the ones I want. Because you're going to have a lot of values in there that aren't really relevant to the hydraulic model. You may have building temperature, amperage, intrusion alarms, things of that sort, which really aren't the kind of things that you need in the hydraulic model. So you got to select out of all those tags that you have in the SCADA system, which ones am I interested in? Okay. From that, you can actually view the SCADA data in WaterGEMS. It's almost like its own human-machine interface. It's there. The data can be graphed and looked at in tabular form. So that's what we do on the SCADA side of things, just to start with. On the hydraulic model side, what we do now is you can create SCADA elements. We'll show you how to do that in the demo. So these are just little elements. Those elements have to be connected to a model element. Okay, you just don't have a signal floating out in space. Instead, that signal has to relate to a pump or a tank or a pipe, something like that. And then you have to associate that element with the signal. So we got to bridge this gap here between the signal and the SCADA element. And then once you have that, you can view and use the SCADA signal and model elements together everywhere. It opens up the door to viewing these things in flex tables, in color coding, annotation, all the powerful tools that we have in WaterGEMS for visualizations. I mean, these are things that you didn't quite get when you use observed field data, for example, as a way to add SCADA data to a graph. This is some pretty unique things that you can do once you use the SCADA signal element. Okay, so now we're going to switch gears and get into and actually show you what this all looks like in the model. Okay, just as a review for some of you who may not have seen the earlier talks, the SCADA data looks like this. We have a couple thousand rows of values for outlet pressure, tank levels, pump flow rates, and a date and time field over here on the other side. So this happens to be an Excel chart, but it could be pretty much any kind of historical database file. That whole list I gave you. All of that stuff will work. Okay, so that's what our data looks like on the SCADA side of things. And now we need to get to work doing things with it. Okay, here's where we've created the signals. Okay, so to create a SCADA signal, just like any other signal, you just go to SCADA element and place it. So what these things look like, we zoom in on them, are just these nice little signals like this. Okay, so then you have to associate them with a particular element. So what you would do is grab this one, place it somewhere here, double click on it to get the property grid, and you say, what model element is that associated with? So I'd select my model element, and let's say it's a pipe flow. So let's just pick this pipe. So it attaches it to the middle of the pipe. And from there, you can, pretty much, that's what field is it is the next thing you got to say. So in this case, I want to have flow as the field that I'm going to get. At this point, there's no value. 0 is the flow element because I haven't run the model lately. Okay, and then these fields here relate to the signals that you mapped in. So this is how you create those SCADA signals. Just make sure you have a model run available here for results. Okay, so now how do we tell the model where the SCADA signals are? Okay, go to Components, SCADA Signals. Okay, and I have some set up here, but let's just be brave and set up a new one. Now we have, again, different ways of getting this data. You can get it from a database source or an OPC server. We also have some special ways to get it from SciTech. Now there are two kinds of ways we treat the data. We treat real-time data where we're just looking at the current value of that signal, or historical data where we're looking at a whole time series. Okay, in this case we're just going to say a new database source. Okay, and you get this dialog open. So the first thing it wants to know is what kind of connection is it? What am I looking for in terms of format? In our particular case here, we have some data from 2006, so we're going to look at an older Excel format. And it says, where's this file? Well, I happen to have this file on my computer, so I'll open up the file. And now we'll see, is this file recognizable? Is there good stuff in there, or is this something where we don't have a good connection? And we see that the connection is succeeded, okay? We can do other more advanced things. We're working with SQL servers and this sort of thing. We'll just keep it to the basics right now. Okay, so we get to this dialog that says, okay, if this is an Excel spreadsheet, which table do I want? Okay, in this case, I only have one, so that made it pretty easy. Now, which of those two formats is the next question? Is it that one value per row, or is it multiple values per row? Remember when we looked at the Excel spreadsheet, it was just one value per row. Now we got to say which column corresponds to what. The first one is, what's the signal name? Okay, and we called that file, if you remembered, it was called description. What field is the value in? It's in one called value, which we happen to name it that. And then the timestamp field, we called date time. Okay, and then we have this quality field, and in this case we had quality as the name of the questionable or not questionable field. So there we are. We have defined now where the data are and what fields are we going to use out of each record. Now we say this is historical data. We want a whole time series. We're going to go with historical data down below here. And then we're going to go and say which of those signals that are in the SCADA file do we want. And we see here, when we open up this dialog, we have other data in addition to stuff we want. We've got things like turbidity. Well, we don't really care about turbidity right now, so we're not going to bring that over. We do want most of these other fields. So we want flow, we want inlet pressure, we want outlet pressure, and we want tank level. Okay, so we say that, and now we have essentially defined our SCADA connections. All right, and there they are. Okay, we can just look at them directly right now. We can just take one of these things, take one of these, and we need to set the time, of course, for this, because we don't want to bring in all the data from 2000 to 2015 because it's not all there. There's just be a few points in the middle. So what we have to do is remember where our time was. In this case, we were 8 months in the year 2006 is the time period that we were covering with this. We started at midnight, and we went to 8/4/2006. And we'll just go to the current time right now. So we'll refresh this, and we'll go out there and see if that data is available. It's loading data, and there's our data. We have a tabular list of all the data, and this happens to be like 2.5-minute data, so there's a lot of data out there. And then we get a graph. And we have a choice here. Any data that's marked as questionable, we could include or we don't have to include. So you have a choice of showing it or not showing it. So this is the first path through the data. We have the data, it's available, it's being read, and it's being displayed. So you can use this as a way to just view SCADA data. But there's more to it than that. So we'll say, okay, so now what we have to do is build these mappings between the SCADA elements and the signals. Okay, so we go SCADA element here. Just open the dialog. Okay, so now we have a pump, and we say, well, pump corresponds to the flow data, so that's good. We have this one, and I already set these up, so I probably should be showing it. This is out of the list of signals. It tells you which signal it's getting. And this guy here is getting the signal from the pump suction side. Now this one here, we don't really have data for, so I'm going to delete this one so it doesn't clutter up our displays. And that's gone, and I could zoom back out here and we'll look and see that we have tank data as well. There's the tank data, okay, and it's tank T1 is corresponding to signal element 4. Now you can give these signal elements better names than SE4. You might want to give it some name like tank signal, but you don't have to do this. This is just an optional thing you can do. There we go. Okay, so we have changed the signal name for that one. Now, what good is this? Well, we have to go and look at it a variety of ways. One of the ways of looking at it is to take this signal and graph it. And there's the tank data, and let me see where we did with the signal data. Okay, let's look at the signal from this one right now. We'll check on the tank in a minute. Okay, so we see here, this is the pump flow rate. We see sometimes the pump's off, sometimes the pump's on, and this agreement here isn't really all that good. So this tells us we got to do some model calibration work to get these things to agree a lot better. I had this looking better earlier, so I'm wondering what I did differently right now. But the data are, can be by tweaking the model, of course, you get the data to better match the real system. Now we see the flow rates are pretty good when the pump is on. It's giving us fairly accurate flow rates, but we see that the time signals are not matching up that well when the data actually starts. And try to look at this tank one again here. And also we have the ability. Notice that the data, the times didn't exactly overlap perfectly. So we go up here to our time browser and move to some period we know is kind of in the middle where we have data for both. And we can go in here and see the data. We see here that we have pump data. Says it's 1232 GPM. Historical signal says it's 1002 GPM. So its difference is 30 GPM. Now, is that good enough for your model or not? We have to think about the situation and the quality of the data. We can also get into flex tables for SCADA element data. So here's our SCADA flex table, and we see here that have a lot of data that I've got to define because I got some historical signals here. Looks like I only set up the flow rate. I have yet to set up the tank. I thought I had done that, and we just have to tell the system where to get the tank data from. But we see here that the pump data we were looking at, the field is flow, and we're looking at historical data values. Here's the value from the SCADA system. Here's the value from the model element, and here's the difference. And then you can also have alarm signals as well. So let's go back in here and look at the tank again. Make sure we're mapping it to the right signal. So we didn't really tell it yet. And the reason I was getting no values here is I hadn't filled out this field where I got to tell it where does it get that value from. So this is tank data. So now we should pick the right one. See, this is the problem. I have two different tank things there. Okay, there's our data. So now we have tank data. In that case, now we have not a really very good agreement. We're out by 5 feet. So we got to do a lot of model calibration in this case because the tank data shows that the model element and the historical data don't quite match up at this particular time. As we move the time slider to the next time step, we can look at the next value and see how far that is off. So we have the ability to actually look at the data in the property grid, look at the data in the flex tables, and we can do pretty much anything else that we want to do with model elements. For example, we could go in here to element symbology, and one thing we can do if we don't want to have our models all cluttered up, we can just turn off the signals. Or we can go in here and add, say, annotations. And for the SCADA signals, we have a whole bunch of things that we could add. So we might want to say, okay, which model element is associated with that SCADA data? So I say model element and apply, and I now have the name of the model element right next to the SCADA signal. So you could look at both the SCADA name and the model element name. So you can basically do anything that you can do in WaterGEMS with other elements you can do with SCADA signal elements. Okay, that brings me to a conclusion of this particular presentation. I hope you've enjoyed it, and we'll listen to the other water special interest group presentations. We have a lot of good topics coming up in the future. Thank you for attending.